In the second normal form, we indicate only non-key attributes to be dependent on the key attribute only. Clear? But we are not told what type of key it is. Okay. Only all non-key to be on the key attribute. At the same time, it should not contain any transitive dependency. What is the transitive dependencies? If A derives B, B derives C, A can derive C also. Okay, indirect dependency. When come to the BCNF, we are having a strict representation of this functional dependencies, one of the most desirable form, where it is indicating the alpha derives beta, each and every functional dependency in the F closure. Alpha derives beta. Okay. The each and every functional dependency is telling us how one column is depending on another column. Alpha is nothing but a set of columns, beta is a set of columns. If alpha derives beta is a trivial functional dependency. What is the meaning of trivial functional dependency? Beta is part of the alpha, or beta is a set of alpha. Both the right hand side, whatever the right hand side the columns contains, it is also available on the left hand side. Okay. In such case, we call it as a trivial functional dependency. It can be a trivial functional dependency. Usually, we never contains the trivial functional dependencies. We use only non-trivial functional dependencies only. In case of the non-trivial functional dependencies available, the alpha must be a super key. The left side unnadi super key matrame ayi undali. Non-key attribute is nothing but a super key. All non-key attributes must be depending on the super key only, or left hand side of the super key. That super key can be a candidate key or nothing but it is a primary key also in the practical implementation. So left hand side of primary key matrame undali. Okay. But here we are in the theory, we are not saying it is a primary key, we are saying it is a super key. Alpha must be a super key only. Okay. So when alpha is a super key, strictly it is maintaining dependency of the all other non-key attributes on this primary key attribute. Okay. But sometimes when you are dividing the particular table, in order to avoid the redundancy, it may not possible. We'll see a case. Okay, we will see a case study. In such case, the table, whatever the decomposition may not satisfy the BCNF, then we require an alternative decomposition. We need an alternative normal form. Okay, the alternative normal form is the third normal form. The alternative normal form is the third normal form. Okay. What the BCNF is saying, all non-trivial dependencies of the form alpha derives beta. Alpha derives beta is nothing but a functional dependency. Later we'll see maybe in the future a couple of functional dependencies we'll identify. We'll solve some problems also. Okay. Where alpha is a super key only in all functional dependency, where alpha is the set of columns, beta is a set of columns. When we are having a functional dependency, alpha derives beta, and the first column there is the second column there is the telialsan column, alpha column must be a super key. When come to the third normal form, we are giving some relaxation. We are giving relaxation to this particular rule, where alpha need to be a super key. In the third normal form, we are giving a relaxation, where in the BCNF, in the alpha derives beta, alpha must be a super key. Okay, right? We'll give the relaxation that it need not be a super key. We'll give a relaxation that alpha need not be a super key. Okay. So what is the difference between BCNF and third normal form? In the BCNF, the functional dependency alpha derives beta, either it should be a trivial functional dependency, or it should be a trivial functional dependency, or alpha must be a super key. Alpha must be a super key. ఆ టేబుల్లో సూపర్ కీ ఉండి తీరాలి, లేదా ప్రైమరీ కీ ఉండి తీరాలి. When come to the third normal form, we are giving a relaxation. In case of the non-trivial functional dependencies, left side need not be a super key. Super key కాకపోయినా table divide చేయొచ్చు. Okay. So before once again going to that particular rules in the third normal form, once again the super key is nothing but a candidate key. Anything adding to the super key is also a super key. One of the candidate key is a primary key, or when a candidate key is a minimal super key, we can call it as a primary key. Clear? So when come to the super key, no proper subset of which is also a super key, we are going to identify as a minimal candidate key. When come to a super key, when no proper subset of a super key is also a super key, then we can treat that particular key. అంటే సూపర్ కీలో మళ్ళీ ఏదైనా డివైడ్ చేస్తే డివైడ్ సూపర్ కీ కాకుండా ఉంటే దాన్ని క్యాండిడేట్ కీ విత్ మినిమల్ కాలమ్స్ ఆర్ మినిమల్ సూపర్ కీ అని అంటాము. ఓకే, నథింగ్ బట్ అవర్ ప్రైమరీ కీ ఇన్ యూజువల్ కేసెస్. క్లియర్? రైట్. సో in the normal form, BCN of normal form, the left hand side of the functional dependency must be super key, okay, or a minimal candidate key, that is the form of alpha derives beta. When come to the third normal form, we'll see the cases with reference to the F closure. F closure and a set of functional dependencies like alpha derives beta, beta derives gamma, gamma derives A derives B, B derives C. All these are set of F closure. Okay, so we are having set of functional dependencies like alpha derives beta. The derives, the arrow symbol is indicating a functional dependency, where left hand side we are having a set of columns like alpha. Right hand side is we are having set of columns like beta. Okay, right. So in the third normal form, when you can declare it is a third normal form, alpha must be proper subset of the relation R, beta must be a proper subset of relation R, alpha derives beta is a trivial functional dependency. That means beta is part of alpha, or alpha is a super key. These first two rules are as it is from the BCNF. We are having an additional rule. We are having an additional rule. When an attribute A, when any attribute, okay, the attribute beta minus alpha, ante right side ఉన్న కాలమ్స్ లోంచి లెఫ్ట్ సైడ్ ఉన్న కాలమ్స్ తీసేస్తే ఏవైనా ఉంటే, రైట్ సైడ్ ఉన్న కాలమ్స్ లో లెఫ్ట్ సైడ్ ఉన్న కాలమ్స్ ఏవైనా ఉంటే అవి రిమూవ్ చేసేస్తే రైట్ సైడ్ యూనిక్ గా ఏ కాలమ్స్ అయితే ఉన్నాయో, రైట్ సైడ్ ఏ కాలమ్స్ అయితే యూనిక్ గా ఉన్నాయో నాన్ ట్రైవల్ ఫంక్షనల్ డిపెండెన్సీ, యూనిక్ గా రైట్ సైడ్ ఫంక్షనల్ డిపెండెన్సీలో రైట్ సైడ్ ఉన్న కాలమ్స్ క్యాండిడేట్ కీలో పార్ట్ అయితే కంటైన్ ఇన్ ద క్యాండిడేట్ కీ. Okay, we can take it as a third normal form, or else alpha need not be, or else alpha need not be a super key. Left side of the functional dependency need not be super key. Okay, so the third condition that does not saying that single candidate key must contain all attributes. Single candidate key need not contains all the attributes. It need not be a minimal candidate key. It need not be a minimal candidate key. Primary key minimum candidate key ayi undalsina avasaram ledu. Okay, right side ఉన్న columns attributes ఏవైతే ఉన్నాయో, it need not be form a single candidate key. It can be spread across the number of candidate keys. It can be in fact any candidate key. It need not be primary key. That is the meaning is it need not be minimum primary key, because any particular table, we are having one and only one primary key. Super key in Japtondi, that BCNS in Japtondi, it must be a super key. We are treating the super key as the minimal candidate key, which is nothing but a primary key. So in those keys, left side is a primary key, one and only candidate key, one and only primary key. Okay, whereas we are giving a relaxation here. Whereas here we are giving a relaxation, it need not be candidate key, or it need not be unique candidate key, or it need not be minimum candidate key, or okay, it can be any candidate key, any key, fine. So once again, whenever we before that when we declared the keys, we identified a table contain n number of candidate keys. A table can contain n number of candidate keys. Some of the candidate keys can be super keys. One of the super key is going to be the primary key. So in this particular case, we can have any candidate key. It need not be super key. It need not be primary key. It can contain in any candidate key. Only thing is B minus alpha. Right side on the attribute, left side on the lakunda unte chalu. Left side leni, right side on the attribute edina sare. Left side leni, right side on the attribute edina sare. You can treat it as a candidate key. Generally, we use in case of the transitive dependencies. Okay, right. So it can be contained in any or different candidate keys. That is the relaxation. That is the difference between BCNF and third normal form. Where is the BCNF? It must be a super key or candidate key or minimal candidate key. Whereas in the third normal form, it can be any candidate key. In the third normal form, it can be any candidate key. Okay. So the first two alternatives are same as two alternatives, whatever available in the first BCNF normal form. Okay. But when come to the third normal form, it can be in the third normal form. Okay. The third normal form of defines uniqueness, okay, or obvious. We'll see why it is useful when come to the BCNF. Okay, right. So it represents in some sense a minimal representation of BCNF, minimal key representation of BCNF. That condition helps the minimal representation of minimal candidate key relaxation of the BCNF condition helps to ensure every schema has a dependency preserving decomposition. Until unless we say whether the left hand side is a minimal super key or candidate key, minimal candidate key or primary key, if it is not satisfied, we can't preserve the decomposition. Okay, dependency preservations. Okay, so if the conditions are not satisfied, the minimal relaxation of the BCNF condition can ensure us dependency preservation, decomposition. Okay, with an alternative, right. So before going to the example with reference to the BCNF and third normal form, the only difference between the BCNF and normal form is we are giving relaxation. Left side need not be a super key. It can be part of any candidate key. Okay, so that we are observing that any schema that satisfies any schema that satisfies BCNF automatically satisfies third normal form. Okay, because the rules required for the BCNF, one is either trivial functional dependency, or second is super key is also part of the third normal form. Only the third normal form is having one rule. Only third normal form is having one additional rule. Okay, since each of the functional dependencies satisfies one of the first two alternatives. BCNF is therefore more restrictive normal form. BCNF is more restrictive normal form when compared to third normal form, because there is a relaxation in the third normal form where alpha need not be super key, it can be a part of any candidate key. Where BCNF, we are saying it must be super key. So BCNF is more restrictive normal form when compared to the third normal form. Okay. Why you are using the third normal form? When there is a condition not satisfying the BCNF or unable to identify either trivial functional dependency or unable to identify after decomposition, left hand side is a primary key. Left side is a primary key. Okay, that is the problem. Okay, so the definition of third normal form allows certain functional dependencies that are not allowed in the BCNF. The definition of the BCNF allows certain functional dependencies that may not be available allowed in the BCNF. Okay, right. So once again, a dependency alpha derives beta that satisfies only third alternative of the third normal form. If any functional dependency is satisfying only third alternative of the third normal form, be careful, it is not going to be in the BCNF. It is not going to be in the BCNF, because sometimes we may get some questions whether the functional dependency is satisfying a BCNF or not. Whether it is satisfying BCNF, whether it is satisfying third normal form, whether it is satisfying both, we need to identify. We need to identify, right? So till now, whatever the theory I covered is indicating some tables whenever you want to decompose, okay, into the BCNF, say it is not satisfying the BCNF rules after decomposition. Even after decomposition, the tables need to be either contain trivial functional dependencies or left hand side must be super key. Okay, right. Let me take a small example. Where in the particular example we are having student ID, student name, city, and zip code. Student ID, student name, city, and zip code. Okay. So why we required this particular thing into normalization or decomposition? First of all, if you are identifying this particular thing, this particular table is containing student ID. Probably you may declare it is the primary key. On student ID, student name is depending. On student ID, student name is depending. Okay. Then city, the student where he lives. Okay, city also depending on the student ID. Then zip code. As part of the address, we are providing the zip code. The zip code is with reference to the city. The zip code is with reference to the student city. Many number of students may reside in the same city. The same city is having the same zip code. The same city is having the same zip code. So here, what is the functional dependencies? Okay, student ID is the key. On student ID, we are having city. Okay, on student ID, we are having the city. from the city, you may get the zip code. Clear? What is the thing here? We are having the student details where we are maintaining the student ID, student name, city, and zip code. All the student name, city, zip are depending on the student ID. But here the thing is, zip code is not depending completely on the student ID, but it is also depending on the city also. Clear? City is depending on the student ID, zip code. Of course, indirectly it is depending on the student ID. You can say if you give the student ID, you can go the zip ID where he is residing, but zip ID is also related on the city. So there is a transitive dependency. So there is a transitive dependency. We need to divide. We need to divide into two tables. Okay, whatever the number of codes it is. Okay. Here the thing is, from the student ID, you can identify zip code. From the zip code, you can identify the city. Or from the student ID, you can identify the city. From the city, you can identify the zip code. Anything is possible. Anything, both are correct answers. Okay. But when you are dividing into two tables, okay. Say for example, if it is a city, okay. If you want to divide this into the two tables, either the city and zip code need to be in one table. But when come to the say, for example, city is can't be a super key. Student ID still after decomposition also, student ID after decomposition also is eligible to be a primary attribute. Okay, is eligible to be a super key. Okay, but what about the city? If you say student ID, city, from city, zip code, this number of students may reside on the same city. Okay, in the particular table, city is not eligible to be a super key. Not eligible to be a super key. Okay, but you can identify city as a candidate key, no problem. Okay, based on the candidate key, the purpose of the super key, candidate key, all those things are not only to eliminate the redundancies, but also to make indexing also, to make fast operations also. So in this particular purpose, not only we are creating one primary key or super key, but also you may create n number of candidate keys also. But if you want to divide this particular table into two tables, the city is not eligible for a super key, okay, but it is eligible as a candidate key. But it is eligible as a candidate key. Okay. So if you want to divide this particular thing, it can't be in the BCNF normal form. It can't be in the BCNF normal form, but this particular division is eligible under any candidate key. Okay, any candidate key, so that we can comes under third normal form. Now you can divide. You can make city as a key and zip other field, or you can take zip as a candidate key. Okay, because if you know the even the zip, you know only the city, you can't get the other values. Okay, similarly city also, it may zip also, maybe if it is repeating for the number of students. Student is ID is ultimate. In every table, every student information, you may get one and only one student ID. But you can have n number of zip codes of same value. You can have the same city number of times. You can have same city also number of times. That is the reason those are not eligible for super keys. But they can be identified. But they can be identified as candidate keys. Okay, they can be identified as candidate keys. అంటే జిప్ కోడ్ తెలిస్తే మనకి స్టూడెంట్ ఐడి నేమ్ అవన్నీ తెలియవు. బట్ స్టూడెంట్ ఐడి తెలిస్తే మటుకు సిటీ జిప్ కోడ్ అన్ని తెలుస్తున్నాయి. అందుకని స్టూడెంట్ ఐడి యూ కెన్ ఐడెంటిఫై as a super key. But when come to the zip code or city, it is restricted to only a small part of that particular table, only. Okay, and you can identify as a candidate key. Okay, if you divide this particular way, you call it as a third normal form, where the zip code or city is not that much worthy for as a super key, but it can be identified as a candidate key. Okay, so this is the third normal form, where after decomposition, one of the key, whatever we are identifying as the candidate key in maybe probably second table, may not satisfied for the super key, but can be taken as candidate key. Okay, part of the candidate key. You can identify it as third normal form than BCNF. So in the BCNF, all the remaining keys are truly depending on candidate key or super key only. Okay, right. So with it, we can conclude this third normal form, or up to the first normal form, second normal form, third normal form, BCNF. In the next class, we identify a different sort of functional dependency. Here, what it is meaning, zip derives city. If you know the zip, you know the city also. If you know zip, you know the city also. But if you know the zip, if you are getting the many cities, say for example, if you are many cities having the same, if the city is having many zips, or city is having many zips having the same city name, like Hyderabad, one in the India, one in the Pakistan. Okay, then such dependency is called with a different name. In the next class, we identify such other forms of the functional dependencies, where you can identify, okay, some sort of relevance between attributes. Okay, right. So with it, I am concluding it. Now give your attendance.